Hello, people. How you doing?
Hi.
So today we're again going to try to stay on track with the presentations, etc. Though too. So it's going to basically be the idea is 7 minutes of presentation and 3 minutes of Q&A, which I understand is not awesome, but we'll try to roll through this. The jury, quite honest, it's going to be, and I don't know if you want to be outed on this. Didn't quite ask you on this, but it's going to be Lauren Dandridge, Jennifer Siegel, and myself, who are a very competent, very wonderful jury, and I'm glad that they've agreed to do this as well. So I don't know if Ludmila is in here yet.
I'm here. Hello.
Fantastic. Ludmila, would you like to start?
Yes. So please let me know if it would be no sound or something happened.
Okay.
So I'm sharing my screen.
Great. That's looking good.
Hey, Scott. Hey, Lauren.
Hey, Jen. I already did a brief introduction. If that's okay.
Okay. Okay.
Ludmila, are you presenting right now? Because we don't hear anything.
Yes.
Are you going to share some sound?
So yes, I'll do that again because looks like
A little bit of technical difficulty.
Yeah.
Okay.
Thank you for letting me know.
Okay.
Yes, I'm doing again. So please let me know if everything is good.
Sure.
Sharing. Office buildings in Los Angeles typically have high energy consumption intensity. As a result, vulnerable communities across the Los Angeles area cannot afford to build them and use for dire needs. However, by adopting certain design strategies and incorporating PV panels, it is possible sufficiently reduce the energy demand. The Social Moire project is in the boundaries of GASP confirmed Arroyo Seco specific plan. The GASP covers 6,600 acres of land in Chinatown and Lincoln Heights. The project site is in the boundaries of the LA River Buffer area. The area covers 20,000 square feet. The Urban Moire project provides many options for occupants. Its flexible environment has massive potential in every sector, such as wellness, technology, and different working environment. In accordance with LA plan, low-cost co-working space can significantly help to reduce homelessness by 2028 by providing more business opportunities and helping local communities to become stronger and prosperous. Design principles of the Social Moire project, affordable co-working space and educational center, were tested to evaluate the building performance. As designed, phase calculation includes CLT existing wall efficient construction, HVAC air-to-air heat pump, low E triple glazing. As improved phase calculation includes west-south part wooden buttons fence density calculation, cool roof contribution and energy demand reduction, overhangs of the east-south part of the site, PV and BIPV calculation. Methodology Part 1. The climate features were collected via climate consultant, Revit sun and shade simulations, and Revit Insight solar radiation analysis. Methodology Part 2. To prove proposed design principles of the Social Moire project, Design Builder platform was used to make a virtual model and evaluate the building performance. The project was done in Revit BIM application and model was exported to the Design Builder software. The Design Builder is an interface for the Energy Plus software. It supports detailed mechanical and electrical system data. Final energy analysis includes the building envelope, exterior wall overhangs, and glazing type type proposals, as well as HVAC system and PV panels demand to approach net zero protocol. First phase of simulation, as designed, includes three main architectural strategies: CLT exterior wall efficient insulation construction, R21 3.7 density, U factor 0.057, low E triple windows glazing, E5.1 argon, and air-to-air heat pump as HVAC source. After the features were applied, the simulation was done. Graphs and tables were produced. There are the fuel breakdown, the temperature and heat gains, the temperature and heat loss. And the end-use summary table was generated. The second studying phase was as an improved phase. In this phase, another three architectural strategies were tested. The first one was the west-south part wooden buttons fence density calculation. As a result, the 40% of solar transmission was the most efficient for the project. The next improvement feature was overhangs of the west-south part of the site. The features were applied to the model by using design builder settings. The last improvement component to study was a cool roof contribution in energy demand reduction. The initial result was a comparison of two phases, and it shows that three tested designs of the project buildings. As a reference for findings, California Building Energy Benchmarking Program data was used. It shows the energy use intensity mean among more than 2,000 California office buildings is about 3,300 kBTU per square feet. To drive the project to the net zero level, the necessary amount of photovoltaic panels was calculated. One more run of the simulation shows the contribution of two project buildings' photovoltaic layouts. The primary result was a correlation chart that shows that calculated amount of photovoltaics was enough to cover the energy demand of the project. The integrated result of the case study is an algorithm that can be applied to future researches and projects. This algorithm explains that the simulation analysis can be applied on different phases of the project from the very beginning to the final stage of the process. To conclude, that it's useful to have such simulations for communal affordable co-working spaces and educational centers. The outcome can be possibly disseminated widely. This work increases knowledge of how to make an affordable co-working space in order to approach diversity, equity, and prosperity of local community. It could help create new building typologies and design solutions. In accordance with LA Plan, low-cost co-working space can significantly help to reduce homelessness by 2028 by providing more business opportunities and helping local communities to become stronger and prosperous. Thank you.
Ludmila, nice, right on time. I love that.
Yeah.
Very good. You know, again, I think I have a probably not super fair question, but I am interested on sort of what is the concept of design justice that affected your project beyond necessarily the idea of PV and insulation and, you know, high intensity glass. What are the other features of your project, or how did that tune your project to the?
So I did not present it today because it was part of the studio project, but it was designed to accommodate needs of very low income communities.
Yeah.
When people struggling to find the job and to place where they can communicate with each other, have sources. And I did those projects to be very open to the young people from the community and from people in any age. And it's a 3-story building with a communal garden to provide more jobs. It's also library there and theater. And it actually its name is Hope. So I mean, I'm at that time I thought how to have that good place to start your business or to continue your business in a very difficult circumstances.
Very good. I don't know if anybody else has questions. Okay, I think we'll just try to keep things rolling, and we're going to go to Kennedy Wells. Cool. Good timing, Kennedy.
Okay.
Not quite full screen, but it's on screen.
Yeah, okay.
There you go.
Hello and good afternoon. My name is Kennedy Wells, and this is my presentation on biodegradable material and how it can be used in housing. Previous movements in dynamics and architecture, such as metabolism, reflect on the idea of flexibility when it comes to architecture. However, attempted to do so with materials that were inflexible in nature, such as concrete and steel. When it comes to buildings like the Nagin Capsule Tower, you have the problem of creating a system that needs high maintenance and has embedded technology that prevents evolution. Steel and concrete create a time capsule rather than something that can develop and change. This leads to the issue where we have a partially abandoned building that is too expensive to remodel and too expensive to destroy. At this point, the destruction or remodel, we have a huge issue of waste. But the answer to this is multifaceted. However, by understanding the life cycles of buildings and the context of larger ecological systems and creating buildings that decay organically into the environment, we can create ethical cycles of construction that keep up with the evolution of technology. Buildings are demolished mostly because our society has moved past the need for them rather than their material longevity failing us. Most of these buildings do not last, are made of steel and concrete, not to correlate the two, but to show that we build a large portion of buildings out of these materials for them to barely last 25 to 50 years. Yes, these are recycled, but somewhat, but it costs energy and pollution, at the cost of energy and pollution. So by turning to more biodegradable options, we can greatly reduce our carbon footprint and waste production. I chose mycelium. Mycelium is a great material because it does not need artificial energy to grow. It lasts 20 years. It takes 5 days to grow. It is cheap to produce and is fire resistant and mold resistant. It can be made into bricks and paneling depending on the shape of the mold you put it into. For my project, I've decided to use wood as a structural component, as mycelium is strong, but is not structurally sound on its own. For my project specifically, I've chosen the Valley Oak wood, as it naturally grows in the area of Santa Monica, and it is strong, fast-growing, and native. This way we can restore some of the native planting to the area whilst constructing housing. I've chosen the site that I've chosen for the project is this old Santa Monica Airport. It is a large parcel of land that would be slated for new construction in 2028. Unlike its previous use, which carried it only to the wealthiest, dedicating this parcel to housing and urban forestry gives the citizens of Santa Monica much needed housing and green space. The part I've chosen has been overrun with invasive species and still has much more of its natural slopes, which is ideal for native landscapes. Working along with the Rios plan, the community will be planted with valley oaks and other native plantings. So my design has housing, a valley oak forest with trails, a system to collect rainwater for landscape, and solar panels. The mycelium processing area and the wood processing area utilize existing airport buildings, it is important for this to be done on site to keep construction as environmentally friendly as possible. First, the wood for the wood process. The wood is being chopped down, then brought to the wood processing to be reshaped for parts of the structure. Then the wood is brought to the housing area to be built into the structure. The mycelium process area is where the mycelium is grown, molded, and dried. The whole process takes over 5 days to create panels to create the walls. First, the substrate is sterilized and used so the mycelium can grow on it without risk of infection. Next, the mycelium is tightly packed into the mold and left to set. The mold is left to dry and grown into the mold further. Then the mycelium panels are brought on site and built. First, this community starts as a grove of valley oaks. At first, the community is relatively small, and it has a small community center to boot. As it builds, the program of the buildings can change, become bigger and smaller, and depending on what's needed over time. The program can change from housing to a more mixed use or commercial if needed, depending on what the area demands at the time. As the building begins to decay, it becomes a new typology, a remnant of the space that used to be. This material will be left to decay or be reused. Then the land will be allowed to follow. In its space, new oaks will grow. This will allow for controlled use of these native trees to make sure they regrow in the place of trees used. The housing originally was a mixture of different size housing to cultivate a community of different lifestyles and backgrounds. The decaying stage will allow for new types of infrastructure to emerge. Like Gasworks Park, spaces like this show the structure once was there. This curated fixture will show the beauty of the organic decay of space. The final stage is the return to the original state. This will allow for the urban forest that the community can utilize for a great green space. Thank you for listening, and does anyone have any questions?
Cool, Kennedy. So you're saying that the decay, you think, is about 5 years or something of that nature? I mean, I think it's fascinating. I love it. But,
Wait, so what did you say?
how long is the decay process, do you think? Or, what happens at the end of the life? Do you just leave holes in the building, or, is there other ways of I don't know, speeding up the cycle?
Decay. I mean, I think by allowing it to be partly planted will definitely increase decay. Just having a greater amount of ecology in it just brings about more bacteria, more fungus, more things that tear things down. I feel like the 5 years cycle is more of about building less than decaying, but that's kind of the idea. But thank you.
Yeah, really interesting. And I love it because it's the exact opposite of what architects typically are trained to think about, as far as build up and leave it and it's sold as a developer or whatever. This is a really fascinating concept.
Thank you
Very
so
cool.
much.
Yeah, just a quick question, Candy. So the community size that you are showing on this image. So how many people you may estimate to live in this boundary?
140.
140. I see. So just one comment is that if you can estimate some ecological footprint, because the baseline ecological footprint is that ecological footprint is based on our resources that we are but the resources that we are spending and also using for our current life. Based on this speed and rate, we need some two other Earth to provide such resources. So I think it is a really good fit for the ecological footprint. So you may estimate that there are a lot of tools available in internet, and then you can compare any other baseline so that you can specify the merit of your project. Yeah, very good job. Okay, thank you.
All right, so next up we have Jongju Kim. If you're ready, I'm not so sure I see them. Oh yeah, I do. Are you ready?
Hello.
Great.
So I'm gonna share the screen.
Looks like it's sharing.
Oh, sure. Okay. So this is actually this is research 2. Hello everyone. I'm Jongju Kim, a current second-year student in the Master of Building Science, and my research is about development of data-driven, user-centered building facade design guideline models. So during the normal architectural project, and especially during the initial design phases, architect and clients normally have design disagreements. And this is happening because the vast knowledge gap between these two parties. So if there is a data-driven prediction model, they can predict the most significant design parameters based on user information. In this case, the client's design preferences. Architect can use this model as a design guidelines to better understand their client's personal design preferences. So the research mostly addressed the aesthetical function of architectural project. So building facade was selected as the main medium because it always have formed the most dominant visual images of the buildings historically. So this is a simple methodology diagram that describes the overall research framework. So starting from the data collection stage, so the research conducted a series of human subject experiment, which is facade design preference survey, to build a reliable facade design preference data set. So this survey has 50 buildings, and there are 15 design preference questions for each building. And the question is based on the 5-point Likert scale. And in addition, there are really simple questions asking about participants' background information, such as gender and age. And move on to the next stage is, so during the data pre-processing stage, the raw data is filtered to be more compatible. And during this stage, the raw data were used to create two different data sets. First one is entire data set, and the individual. The second one is the individual data set. So there are 37 individual data based on each subjects. And then this data set were used in the data analysis stage, which is the main core stage of this entire research. So there are four data analysis techniques utilized. The first one is statistical method, which is stepwise regression. Stepwise regression was used to identify the facade design parameters that are most influential in determining the final design parameters, preferences, and the rest three machine learning based techniques were used to develop multiple facade design preference prediction models. And during the evaluation stage, this model's prediction accuracy was evaluated, and then the most suitable prediction model was selected. So this is a simple diagram showing the these four techniques. So these four techniques can largely group in two different approaches: regression and classification. So regression approach only read numeric values, and classification approach only read a nominal value. I'm showing this because the raw data only has numeric values. So for the machine learning approaches, the data needs to be converted into nominal values. So nominal value is like a text-based value. So this is the basic contents of the survey. So start from the demographic informations, and then you look at the image. The participants look at the images and start to answer these questions. So the final two questions about the general preference of the final preference of the building. And you can see this is based on the 5-point scale. The number 1 indicates very dislike, and 5 indicates very like. And this is the raw data set, and this data set needs to be was filtered. And out of this raw data set, 2 different types of data set were created. Entire data set basically has every information collected from the survey, and because there were 37 participants, 37 individual preference data set was created. So starting from the first data analysis techniques, stepwise regression analysis technique. So the prediction model was created based on the last question, which is the question 15, asking about final design preferences. And this is the result when you use entire preference data set. And you want to stop when the prediction accuracy between two prediction accuracy is less than 1%. So for this model, step 4 is the last step, and as a result, these 4 design parameters are the parameters that affect the final design preference the most. So you just do the same. I just did the same thing for the 37 individual preference data set, and this table shows the summaries of all subjects results, and then the rest indicates the number, the most significant parameters. And I kind of try to sort it by the demography information, but I couldn't see really great findings. And then now we move on to the machine learning based techniques. So as I said, the numeric values need to be converted to nominal values. So this is how you convert it. And then also the scale size was changes to compare the data with 2 different preference scale. And so when you this is the results of all machine learning based techniques when you use entire preference data set. So out of all this so you look at the error rates, and then less error rates indicates better prediction result outcome. So out of all these models, the best result was created from random forest model with nominal value on 5-point scale. And same thing was done with 37 individual preference data sets. And this all data set was averaged to compare the mean value. And then it's same, the results actually is same. The best results was conducted from the random forest model here. The lowest random forest model, the prediction accuracy error rate is here. The random forest model with nominal value on 5-point scale. And then this data, the average data was also compared with the entire preference data set. And then it's hard to say which one is better because you can see from this table, sometimes it's general preference entire data set has the lower prediction performance, and sometimes individual data set has the lower prediction performance error rates. So in conclusion, multiple data-driven facade design preference prediction models were generated and evaluated based on the collected user design preference data. And stepwise regression analysis extracted a list of design parameters that affect the final preference decision with reliable accuracy based on both entire dataset and individual dataset. But within the collected data, to get the personal result, stepwise regression with individual data is more recommended. And for both entire and individual dataset, the most appropriate machine learning based algorithm for the data preference prediction task is random forest with nominal class attributes on 5-point scale. So similar to stepwise regression, both preference prediction model have reliable prediction accuracy, but individual data set can be used with decision tree to have more insight into the specific design parameters that affect the final building design preferences. And this is a limitation to future work. So because of the limited data size, the data size can be larger, and then the data can be classified based on the demographic information, and then not just aesthetical function, but there could be more design considerations such as layout, interior program layout, or building performance parameters. And then they could be developed into usable applications. And reference And thank you.
June, really interesting. Jong, really interesting. I really like the data collection and sort of the premise of this. The only issue I'm going to sort of poke at a little bit is it does seem like the survey and the data information, and I know you're going to increase data set or whatnot, is an idea of opinion. And I think I'm going to get myself in a little hot water here, but I'm not so sure that mass opinion is is the ultimate awesome sort of thing, especially during certain time periods. I think it's important, but I also, you know, and I always bring up like the Eiffel Tower is one of the things. If the Eiffel Tower was an opinion poll, it would never have been built whatsoever. It was absolutely irrefutably rejected as one of the most ugly things ever proposed for Paris. And now it's the icon of Paris, etc. And you know, again, the Eiffel Tower might be a thing, but it is also slightly frightening on sort of the idea of mass mediocrity, that it's not necessarily a good design or bad design perhaps, but it's whatever is sort of in the medium opinion that will rise to the top of these data polls. Is a thing rather than the data that sort of goes like this. So I don't know. It's just a poke I have at some of the mass things. You know, again, like McDonald's is irrefutably one of the absolutely most popular foods ever, but I'm not so sure you could totally say that the Big Mac is the epitome of the highest level of culinary. You know, although you could make that argument. You know, you could absolutely make that argument that the Big Mac beats any Michelin star restaurant ever, you know, and factually that is true, but I'm not so sure that that's totally true factually as well. So anyway, it's more of a poke than a question.
Yeah, so I mean, but I've been saying this like multiple times, but this is kind of initial stage, and the thing is about this is it's not. People can really expect this to solve everything. This is just like the main purpose is to serve as like a design guidelines they can refer when they start the project. Because based on the study I did, there's some communication hardship between architect and clients. I'm pretty sure you know better than this. Yeah, so yeah, so there's a hardship in communication. So architect maybe can use this guideline model as a way to communicate with clients and as a way to kind of educate the clients, because maybe clients like Eiffel Tower or like some outdated design, whereas it's not making any profit to the clients. So yeah, so this is how they
again, I love the intent. I think that's
yeah.
Very good.
Thank you.
So in order to keep things rolling, let's move to Xingbei Zhang. And my apologies if I'm
Xingbei Zhang.
Destroying your.
There
you go.
So hello everybody, my name is Xingbei Zhang, and I'm second year student of Master of Building Science student. So my topic is the development of AI-driven architectural design guidelines, establish human biometric signal-driven architectural design guidelines as a function of physiological principles. So actually, Junju Kim and I are working on the same topic. So the problem statement is about like we found like architects and clients usually spend a larger amount of time to deciding design agreements due to like misunderstanding about the client's requirements and the preference. So the efficiency of the design process at the architecture design company is based on architect. So maybe after the client changes the idea of the project, the whole project or part of the project will be changed according to client. So it takes time to make the changes and might redesign the project more than once. So the object of this proposed research is to develop an architectural design guideline based on the use of advanced machine learning algorithms. So unlike the current architectural conventional design process, so advanced sensing technologies provide information based on the client's direction, such as physiological signals and the psychological factors. So architects' concept design might provide more opportunities to achieve the client's satisfaction. Also, a better understanding of client's need by architects will decrease the processing time and effort. So this is the methodology of this research. So we are measuring two types of signals. One is biosensor, and the other one is EEG sensor. EEG sensor is kind of like a brainwave signal. So we collect these signals, and also we collect some information from the questionnaire, which is the design preference survey. And also we use 5 different machine learning to analyze the data. And after we analyze the data, we do some model evaluation. So there is 2 kind of models we did. One is general preference prediction model, which is use my data sets. And for individual preference prediction model, I compare my data sets and to Junju Kim's data sets to make sure which model is the best one in this research. So in the future, we hope this research can help architecture firm to predict the best model for best design for the client. So this is the sample of the design satisfaction survey, Junju Kim talked about before. So for the general design preference prediction model, for linear regression, artificial neural network, and random forest regression, I use a 5-point scale in numbers and the 3-point scales in numbers. So 5-point scale in numbers use the number -2, -1, 0, 1, 2 to represent the options of strongly dislike, neutral, and strongly like. And the 3-point scale in numbers use the numbers -1, 0, 1 to represent the options of dislike, neutral, and like. So this is the red column is the sample of the data sets. And for decision tree and random forest classifier, I use a 5-point scale in the nominal and the 3-point scale in the nominal. So 5-point scale in the nominal use the test strongly dislike, neutral like, and strongly like to show the results. And the 3-point scale in the nominal use the test dislike, neutral, and like to represent the result. So the red column is the sample of the data sets for these 2 machine learning algorithms. Oops. So this is the results for the general preference prediction model, which we can see the random forest classifier with the 5-point scale in nominal, I believe, is the best model in this general model. And this is the individual preference prediction models using different machine learning algorithm. So we also did some paired t-test to we found some p-value in the paired t-test, which is all the values are 0, which means my data sets and JJ's data sets. These 2 data sets is 2 significantly different between these two. And this is the decision tree and the random forest classifier. So which we can say like also the p-value is 0, which means like these two data size has like a significantly different between these two. And also like JJ's data is like better than my data. So I also like compare like two different groups. It's like 5-point scale in numeric and a 3-point scale in numeric, which we can see like the 5-point scale in numeric has the better accuracy. And also I compared like which machine learning algorithm in this group has a better accuracy, which I can see like a random forest regressor, which 5-point scale in numeric has like a better accuracy. And also I compare with like a 5-point scale in nominal and a 3-point scale in nominal, which we can see like a 5-point scale in nominal has a better accuracy. And random forest classifier with 5-point scale in nominal has a better accuracy. So in the end, I compare like a best model in numeric and the best model in nominal, which we can see like the random forest classifier with 5-point scale in nominal has a better accuracy. So I did some like a feature importance ranking by using the decision tree, which we can see like the left column, I used like every subject's data set, which we can see like the her red is the most important like a biometric signal. And the red two columns I classified by like different genders. So we can see like for the female, we can see like her red and the skin temperature are the most important feature in this group. And for the male group, the her red is the most important one. So even though like JJ's study based on the survey provide better accuracy, and the higher potential of my research has a potential high enough value to integrate it with design preference solution in the future with some better sides of the human feature information. So that's it. Thanks.
Very good. Does anybody have questions? Okay. I think we'll keep going in the and for expediency itself. But thank you, Jingbai.
Okay,
very good. So Montasir Khan is also joining us from the main control area. But I think we're ready to roll.
I will get cracking right now.
Looking good. That's perfect.
Okay. Hi everyone. I'm Montasir Khan, and I'm here to talk about an analysis of building component energy usage with machine learning, which is a data-driven approach to formulate a guideline. And my committee members are Professor Junho Choi, Professor Mark Schiller, Yaoyi Chiang, and Okyun Lee. So a quick note on our goal to net zero by 2050. Our main considerations are using low carbon footprint materials, using renewable fuel sources, and also improved energy management strategies. And because of accessibility of mass like data, practices of data science can be used to decipher relationships between building metrics. So I did some background research and the building metrics that are like guided by, which are the ASHRAE standards or the Energy Star standards, they're updated every few years. And they're kind of like backdated. Like ASHRAE EUI results still use like data from 2005 building data. So that needs an update, or perhaps a way to kind of like guide them in a more like modern way. So a few case studies that I've done to kind of understand how building components impact energy usage. One case study of how data science is used, it said that machine learning is the future, faster, more organized computation for building energy prediction. Actually, I'm gonna skip this part to save time, sorry. So my hypothesis is the building envelope is a significant factor that contributes to energy usage and should be given more priority in designing like future buildings. Key energy hungry components of a building are ranked, and it is used to establish a region specific performance guideline. So, okay, so my methodology goes like this. It's broken down into 3 phases. The first phase is to organize the data, clean it up, make it ready for the softwares, machine learning softwares or statistical softwares, which I use, which are my strategies, which is in phase like 2, where I use the data in my phase 2 and explore strategies and then find the most impactful like building components and rank them. And in phase 3, I will use like simulations by Design Builder to validate my ranking systems to see basically which components are more important and which are not. So this is like my original data set that I received from like Dr. Okyeon Lee, and it needed to be changed or arranged based on the software. Some software only does numerical data, some only does like non-numeric data. So it needed to be changed. It's explained how I did that in my thesis like paper, which I can provide. And so the first strategy that I explored was statistical like method, where since we have all these building components, all these components are different variables, and stepwise regression can it basically it uses all the models. It uses all the variables and then it picks which are the most important ones. And there's different kinds of like regression, but I use the forward regression, which from the like get-go, it predicts the most impactful parameters to the model. And the key metrics are the p-value and the R-square values. So IBM SPSS is a statistical software, which I used for this stepwise regression. And here you can see the p-value and the this is a p-value and this R-square change value is noted. Now the p-value kind of represents if the variable is significant to the model, it doesn't show how much impact it creates in the model. And the R-square change value is how much impact it creates in the model. Another quick note that I didn't mention is when I say it's impacting on the model, I mean how much impact it has in the overall energy usage. So my main metric that I consider is energy use intensity and like how much impact it creates on EUI. So from the data that I have 18 models, and from 18 models, I have the most impactful parameters for each of these boxes. So for annual 2015, all buildings energy, only the window wall ratio seemed to be the most impactful parameter. Like this, suppose the summer of large buildings in the summer was window glass type, like shading and roof material. So all 18 models are over here. And from that, I get from the frequency of how many of these variables showed in my thing, and also its R-square change values, I could get my regression ranking. So it is in descending order. Occupancy density is seen to have the most impact, then the floor height, then heating system, and the least impact was the window frame type. So then the second strategy I explored was the decision tree method, which is a flowchart like structure. And I use a J48 algorithm, which chooses variables in descending order of significance. I'll get into this a bit more right now. So from my Weka, I use a Weka software to generate my trees. And so these trees, if you notice, each of the highlighted pathways, they represent low energy usage. So each of this pathway is like a configuration for energy use. So for cooling, if I use the chiller, and heating, I use a boiler, then the footprint is rectangular, window type is tilt turn, I get low energy usage. So from this one model tree, I get 1, 2, 3, 4, 5 configurations of low energy usage. Right. So in the same way as my other like table, I have, I broke it down like this. So each model is showing, these are the configurations of low energy usage. And breaking that like further down to create my ranking system, I put the values in. I know it's hard to see, I apologize. But it's basically using the prediction accuracy, which I got from my trees, and the frequency of how many times it showed up in the trees to produce my ranking. So the cooling system over here is seen to be number 1, most impactful, and then the glass type, and then the heating system, and so on. So from that, I get my ranking system, and also the ranking of which components are more popular versus which are less popular. So, and then I got another ranking from Professor like Mark Schiller, who provided his ranking based on his intuition. And I just provided him with the variables. I told him, like, what do you think? And he thought about it and he gave me his ranking. So I can compare the 3 and see which one makes more sense by my simulations. So then my validation begins with in Design Builder, where I made the building based on my existing data set, and the building components that I picked, the HVAC system, wall material, and so on. The baseline was I chose the ASHRAE recommended components. So, and the location was set in Korea because my data set is in Korea. All the buildings that I have are Korean, so.
Montasir, I think we need to wrap it up.
Okay. Okay, I
I
apologize.
don't know if you can or quickly go over some of the main subjects, but I think that's my point.
Okay, for sure. So I have the baseline and the improved components, and I just compare how I changed the model. Then I have the results, how much each component improved to see how the ranking works. So this is my ranking system. A good ranking system would show a gradual like decline in energy for each component. So from this, the 3 comparisons, my decision tree produced the best results. So like better than the human, the building designer ranking or regression ranking. I did another like validation for decision trees, which also checked out. And my conclusion was that the decision tree proved to be a potential option when finding the most effective building components in design, and region-specific component criticality should be considered. And due to the data limitations, a specific like guideline recommendation could not be produced. And this is because the data set lacked granularity, grouping and assumptions limit the specificity of the outcome, and lack in variation of the data set.
All right. I think we're going to have to move on, Montasir. Yeah, I think that's past. So
I apologize, it was long.
Very good. I think Justin Wan is next, and there's 3 more presentations, so we need to scoot as quick as possible if we can. Justin, I don't know if you're playing anything. All right, you got it. But we don't.
Hi,
cool.
Hi, everybody. My name is Justin, and I'm a 4th-year student in the VR program. The project I will be presenting today is Veiled Rays. So Veiled Rays performs as an urban corridor that unifies the 2 lots along Exposition Boulevard, which allows travelers arriving by metro to easily move between the plots, otherwise separated by traffic, and located by the Crenshaw Station, which is the first stop of the metro journey from LAX, Veiled Rays will serve as a city gateway, signifying an inviting entrance into the Crenshaw neighborhood and into the city of Los Angeles. So the challenge of this project was to design programs that serve to improve the community aspect of the site while addressing the issue of homelessness exacerbated by the forces of gentrification in the neighborhood. So the initial reaction to the site was a sense of defensiveness demonstrated through the absence of green spaces and hefty exteriors of the local typology. And in addition to this, the high traffic volume around the site prioritizes vehicles over pedestrians and cyclists, making the site an unwelcoming location for visitors. To challenge this notion, the proposal works to counteract the narrative of a defensive neighborhood by the introduction of park elements. So referencing the site plan, the gateway is situated along Expo Boulevard with the residential blocks located at the back of the site. Excuse me. The two elements are connected by outdoor parks, which invites both visitors and residents to enjoy the outdoor elements the space offers. As can be seen by the gateway's slat nature, Veiled Rays behaves as a screen filtering the scenes and ambient noises from the bustling traffic along Expo Boulevard while opening up to the park plazas to create a pedestrian-friendly oasis in the middle of LA. At times, the structure extends into the turf on the ground and meld into the natural landscape. Not only does this formal language strengthen the gateway's relationship with the park, but also strengthens the occupant's sense of community and relationship with the site. So having decided an appropriate area and volume for the gateway, several operations were undergone to arrive at the final design. The first move was to bend the geometry outward to engage with the community and carving a way to allow vehicular access underneath. Then the geometry is distorted to signify the beginning of the path where the metro station is located by. And in doing this, the gateway also engages with the site. The edges of the resultant mass are then bent to form a canopy that curves from one end to another to obtain a much lighter, streamlined appearance that draws visitors in. Then the location of the two residential blocks are marked on site with the kind of open arm gesture of the U forms, inviting visitors while allowing ample sunlight into the outdoor plaza and into the units. And the three wings are connected by green cores that penetrate through the levels of the buildings at the corners. And the two residential buildings are designed with the intent to provide affordable housing for local community in efforts to resist the effects of gentrification. A total of 510 units of at least 600 square feet in size are proposed in the scheme, providing living spaces for 1,000 to 2,000 people. Co-living lounges are added to each of the three wings for cooking and communal dining, with interior green spaces at the corners acting as wellness zones for residents. To maximize the number of units, the residential blocks are built up to its allowable height of 80 feet. And in each apartment unit, there's a balcony looking out into either the street or the inner courtyard to allow continuous supply of fresh air and ambient sunlight into the living quarters. Louvers are also introduced along the south facade, which is on the right side of the drawing to avoid direct sunlight into the units. Inspired by the WELL and LEED standards, art pieces are hung up along the walls inside the interior green zones, allowing residents to bond over art and nature. Pets are also welcomed in the wellness zone, where residents can relax and enjoy their afternoon reading alongside their companion. And here on the second floor of both the apartment buildings, the podium level overlooks the courtyard and back at the gateway, inviting locals and residents into the park space in lieu of staying indoors. And likewise, the co-living spaces share a similar view into the courtyard to strengthen the connection between the living quarters and the outdoors. And underneath the canopy of the gateway, the scenes of sunlight filtering through the foliage is emulated by the slats and blurring the boundaries between the structure and the park to accentuate the gateway's sense of place in the bustling area. Thank you.
Good. All right. I think we need to keep things going, Justin. So my apologies for that.
No worries.
So Yuxi Wang is the next presenter.
Yeah. Okay. Hello, everyone. I'm Yuxi from the Master of Building Science. My project is the multi-occupancy environment control for smart connected communities. So nowadays, humans' demand for the thermal comfort in the indoor environment has gradually narrowed from a whole building to a small classroom or their office desk. So it seems to be easy to change the microenvironment by using a small heater or small fan, but we cannot carry the heater with us to each public space, like the theater or the library or the bank. So how to set the temperature in such a public place to continuously satisfy all the people in this group? Our project is to aim at thermal comfort control in a multi-occupancy condition in the entire community environment. So in the background research, I studied different kind of factor affecting thermal comfort preferences. I compared many papers about the machine learning algorithm, and most of them figure out that the random forest could bring a better accuracy. And also other research found that the smartwatch is most efficient equipment selection, and also is have a low budget. So this is all the sensor I use in the experiment. People carry the hobo to collect environmental data, and also they wear this kind of smartwatch to collect the physical data like heart rate, stress level, and ETA, also the skin temperature. So after we collect the personal data, we use different kind of machine learning algorithm to build a thermal comfort model and tested which one could perform better in a group. And finally, we did a verification test in a real multi-occupancy condition. So there have 30 people participated in the single occupancy test. They just carry the hobo and smartwatch for a whole week, and they wear it, carry it to anywhere they go, and they give us some feedback of their thermal sensation and thermal comfort level. Also, they record their clothing level and their activity level in every 30 minutes. And there have 6 people participating in the 2 hours multi-person test. And we try to collect more data. So we let them have to wear different kinds of clothes and also to stay in different activity level in order to take more data from that 2 hours. So we build that's all the models we have built for this project. There have some linear regression model, which is built as a baseline. So, and we first use decision tree and random forest to build individual thermal comfort model. Then we simulated this kind of 2 model in a group test, and with some data selected from 30 people. And then we figure out the random forest perform better. So we use it in the final 6 people test. So these are the baseline model. Through this regression line, we can see that most of the regression line are flat. So their correlation is not significant. There is no need to aggregate the physiological variable. And then we use J48 decision tree to build the individual thermal comfort model. So everyone, for the 30 test participants, they have their own decision tree, which is just like the Metasphere, the projects explain it. So when we input their environment feature and physiological feature, we will get their thermal comfort level. Like some of them feel uncomfortable through this kind of feature directions, and the average accuracy of each model is almost 70%. It seemed to be a very good result, but since each person only have 19 records data for training, so there might have some overfitting problem for this model. Then we used random forest to build a compiled thermal comfort model. So the random forest is composed of many unrelated decision tree, which looks like this. So it works by generating multiple classifier models. Each tree will learn and makes their predictions independently. Then these predictions are finally combined into a single prediction by voting. So the performance of the random forest is generally better than that of a single decision tree. So in the compiled thermal comfort model, if we input one's identification features, their environmental features, physiological features, and also their TC is thermal comfort and thermal sensation, the model will predict one's comfort boundaries, which like this. So like from which minimum to which maximum temperature people will feel great comfort at that range. So we also compare the compiled thermal comfort model with the traditional PMV model. So we found that the range of the predicted comfort zone is much narrow than the PMV model. Also, the accuracy is higher than the PMV model. Then we use, when we try to use the model into a group test, we need to have to like a multi-standard decision-making mechanism. So in this way, we have two evaluation. One is the overall thermal discomfort is OTD evaluation. So this way, it will calculate the best temperature for a whole group like this. So okay, so like in this picture, there have 6 people in the group from a range 25 to 20. In this kind of range, people will feel all of the 6 people will feel great comfort in this range. And another way is sensitive first evaluation. So like this, when someone is greatly sensitive for the temperature, the formula will increase the weight of this person's influence, like the green line right over there. If this green line is a children or who will feel only comfort under the 25 degree, the model will calculate in a smaller range than the original OTD models. So there is the result. We select 6 test participants from original 30 peoples. We try to simulate that which kind of model would be better perform good in a group test, like whether the decision tree or the random forest. So from the result, we could see that when the temperature gradually decrease or increase, the OTD, which is the overall thermal dissatisfaction, will gradually increase and more people will feel uncomfortable when the temperature decrease or increase. So the random forest model will perform better than the decision tree model. So then we use the random forest model in a real test. This is the result of it, and the right line is the test participants' thermal sensation feedback, and the right one shows the red line is the environment temperature, and the other line is the prediction by the compiled thermal comfort model. So we could see that when the tester feel very hot, like over there or over there, the predicted temperature will be much lower than the environment temperature during this part. And we also set one person, the tester ID number 4, who feel very sensitive to the environment and the dotted yellow line is the ID number 4, like in this point. In the 2 p.m., the ID number 4, the sensitive guy feel colder than all the other peoples over there. So the blue line is predicted by the sensitive first model, and the yellow line is predicted by the OTD models. So the sensitive models is a little bit much higher than the OTD models, which means that the sensitive first model could feed the requirements of the sensitive people's expectations.
Great.
So,
Yushi, we need to totally wrap it up. I think we have one of the jurors leaving very soon. So, and I think you're kind of going over a little bit. So I don't know.
Okay, there are only 2 pages left. And we also compare with the compiled thermal comfort model testing group, compare with the traditional PFV model. We also find that it could have better accuracy of it. And finally, we compare all of the model we test, just find that the random forest perform very good, whether in the single occupancy condition, also in the multi-occupancy condition. Yeah, that's it.
All right, great. And we are going to Hector Corabias del Sueto. My apologies for, again, butchering your name.
No worries. It's Hector Covarrubias del Cueto. It's called. Almost named it, but it's all right. I'm kind of used to it. I'll dive right into it. I'm going to go ahead and share my screen. Okay. Okay. So Elysian Park, the oldest park in Los Angeles, represented sacred sanctuary for the indigenous communities of the region. In cases of great flooding, communities along the river would take refuge there. Its forests were carefully stored for as they provided shelter, water, and food, as well as a place of sacred burial. The relationship between sanctuary and people was reciprocal. For people saw sanctuary as part of themselves, their elders, and their spirits. Yangna, one of the Tongva's most relevant sites, was located on the banks of the Los Angeles River, close to the area where the park is. Today, this site is a bastion in and against the fight for the pandemic, and also against in case of emergency and natural disaster. This land represents the sanctuary where people in need meet, the cultural convergence points where processions and gatherings from diverse territories convene. Beyond the decimation of the site's ancient forest and the extraction era of Stone Quarry Hills, the major scars are of topographic and hydrologic nature. The area featured 5 ravines. In 1876, Reservoir Ravine was twice dammed. Between 1886 and 1892, the City Parks Commission and other private groups planted 150,000 trees of foreign origins. Solano Ravine became Solano Canyon neighborhood in 1900, and then Chavez Ravine is still there, but its conditions have certainly changed. For the construction of Dodger Stadium, Cemetery, and Sulphur Ravines were backfilled with the top of the erased Mount Overlook, displacing entire communities and clearing 300 acres of land equivalent to 120 city blocks, excavating and relocating 8 million cubic yards of mountaintop into the ravines. What happened with the construction of Dodger Stadium can be seen as a contemporary culmination of a process repeated throughout Mesoamerican colonial history, where the invader-conqueror culture erects construction atop the relevant cultural locations to portray dominance and superiority over the conquered. Some of my research has been oriented towards the Los Angeles County carceral system. It is the largest in the US. It's also the largest mental health institution in the nation. The world's largest non-facility is within a mile from Elysian Park, the Twin Towers Correctional Facility at downtown Los Angeles. I'm gonna skip a little bit of this. Hosts 3,500 inmates with a budget of 3.3 billion, the carceral system of Los Angeles, and 5,600 employees in the Sheriff's Custody Division. Inmates with mental health problems increased 150% from 2010 to 2020. 35% of the entire jail inmate population is in this status. The Conservation Work Program offers services to inmates and recently released ex-convicts, including education-based incarceration, camp training, back on track, substance treatment, reentry transition program, community-based organizations, like Bureau of Community Transition Unit, and also additionally justice-involved programs as the ones provided by Telecare corporations focused on assisting mentally ill, paroled, or on probation individuals. Surprisingly, out of all of these programs, there is not one focused outdoors, given the well-documented healing capacities of outdoor capacities. So in terms of healing spaces beyond emergency and disaster response, particular sites within the park have been dedicated to healing. I want to mention 3 key places: Barlow Respiratory Hospital, established as a tuberculosis sanatorium in 1902, active ever since. The Elysian Park Adaptive Recreation Center, dedicated to helping members of the community with mental or physical disabilities. And Solano Community Garden, emerging from an area prone to neglect and erosion that employed as at-risk youth, ex-convicts, and unhoused individuals, resulting in lower reincidence and providing opportunities for restoring the ancient reciprocal relationship with sanctuary. The experience of Solano Community Garden can be instrumental in replicating this healing power throughout the park. So in working on assessing the potential of Elysian Park area to restore it, the ancient reciprocal relationship between people and sanctuary, that individuals in need can be supported and also support the sanctuary that shelters them, articulating an attractive alternative to existing methods to assist unhoused individuals. Because I believe that there is no reason to criminalize the mere existence of an individual, and in hopes of alleviating the unhoused crisis, supporting the situations of at-risk youth and the mentally ill, and in hopes of healing and recovering the ancestral relationship to the land and the physical and biological manifestations of that relation, these strategies are being assessed in their potential to turn this past and present sanctuary into one where people and land can heal through reciprocity and congruence.
Hector, let's try to speed it up. I'm sorry.
Thank you,
Sorry.
I'm done. Yeah, that was all.
All good.
Thanks.